Okay, question about nuclear radiation, alpha, beta and gamma. First question is just knowledge. You need to know, but by nature, it means what is it actually made of, and then you've got your relative charge. So an alpha is a helium nucleus, which means it's 2 protons, 2 neutrons. Gamma is an electromagnetic wave, just pure energy. And beta is an electron, so you can just put electron. Technically it's a high energy electron that's come from the nucleus, which means it's different to the ones that you find in the electron shells in an atom. Helium nucleus is made of 2 protons and 2 neutrons, but no electrons, so that means it has a +2 charge. Which type of radiation from the table has the lowest penetrating power? So penetrating power is a strange way of saying how far the particle can travel through different materials. We describe it in different ways. So a low penetrating power means that the particle doesn't travel very far. Now, alpha particles travel maybe 2 or 3 centimetres in air. Beta particles travel a few metres, and gamma rays can go for many kilometres through air. So just basing it on air, we see that the alpha particle has the lowest penetrating power. And another way of thinking that is to think about what will stop an alpha, a beta or a gamma, what will absorb it. And we've taught you that for an alpha particle, it can be stopped by a piece of paper, be absorbed by a piece of paper. A beta particle needs a few millimetres of aluminium, and whereas a gamma ray or a gamma wave will need either thick lead or at least several metres of concrete to guarantee it being absorbed. And the observant people amongst you should notice that if the ionising ability is high, it has a low penetrating power. Those two things are inverse to each other. That links into part 3, which types of radiation can be completely absorbed by 5 millimetres of aluminium. Well, an alpha particle can be absorbed by paper, so it can definitely be absorbed by aluminium, and a beta particle can be absorbed by a couple of millimetres of aluminium, so that will also be absorbed by 5 millimetres. Okay, so the next part is to do with the decay equation, and you have to think carefully about your numbers. So your proton or your atomic number is on the bottom here because it's the lowest number, and your mass number, your nucleon number, is on the top, which is the highest number. It's not always that way around. Usually it is, but they can swap them, so just be careful. So carbon-14 is a radioactive isotope. It is decaying by giving out a beta particle. So when you draw a beta particle in these kind of equations, it always has the same numbers. It has a -1 for the proton number, your atomic number, and a 0 because it doesn't have any effect on the top number. Carbon is turning into nitrogen. Now, if you had a periodic table, you could look up the proton number, but you don't need to because you know that in beta decay, it's going to go up by 1. So it's going to turn into a 7. Now, within the nucleus, if you remember, what's actually happening is a neutron is spontaneously turning into a proton and an electron. The electron is the beta particle, so that's what gets kicked out of the nucleus and heads off with all the energy, and the proton stays. So another way of working this equation out is to realise that with beta decay, you gain an extra proton, so the proton number has to go up, but you're just swapping a neutron for a proton, so your mass number, your number of nucleons, stays the same.